So something that's difficult to do with three-dimensional objects on paper is to actually sort of represent the three-dimensionality to people who are looking at the objects you're drawing. And so we've come up with some conventions to deal with that. So first of all, just think simple geometry. 2 points define a line, right? 3 points define a plane. And so if you have more than 3 atoms in a structure, let's say it's a tetrahedron, or if you have a trigonal bipyramid for example, 3 atoms can always be placed into one plane, and that's one of the conventions is we put as much of the molecule as we can into a single plane, which means 3 atoms will be in a plane. So here we have a tetrahedron, and the convention is to put, like I said, 3 atoms into one plane. So what's happening here is this bond and this bond, which are connecting these 3 atoms, right, are in the same plane together. And then what we do is we use a wedge, and we often don't say solid wedge or hatch wedge, but we say hatch and wedge. So a hatch is really this group back here, and this implies that it's behind the plane of these 3 atoms, so it's sticking backwards, and the wedge is coming out in front of the plane of these 3 atoms. So we think of these 3 as in the plane of the paper, this one's sticking out, this one's sticking back. Now, if the molecule doesn't need to be drawn in 3 dimensions, then we don't. So linear, right, we can draw it like this. These are all in the same plane together, but also in the same line because it's linear. But trigonal planar, right, we draw it flat. So all 3 of these atoms, the x's I should say, and the a are in the same plane with each other. Now, bent off a trigonal planar, right, would have a lone pair here, but these 3 would all be in the same plane together. Now, from the tetrahedral shape, we have the trigonal pyramid, right? And these 3, like this is the one we just drew, these 3 are in the plane together. And the way they've chosen to draw this one, but you didn't have to do it this way, right? They put the lone pair, there's a lone pair up here, that's in the same plane as these guys down here. And then that means this has to go forward, this has to go back. Now, if they had chosen to put the lone pair down here, then the x would have been up here, and then these 3 atoms would have been in a plane together. Trigonal bipyramid, we have all of this, these 3 groups here, this one, and this one, all in the same plane. But this one goes backwards and this one goes forwards. And now seesaw, oftentimes they just choose not to show the one over here. And then, so it's the lone pair. There's a lone pair here. That's in the plane with the 2 axial AX groups. And then for octahedral, oftentimes what they do is they show this, that these 3 are on the same axis with each other, and these are going backwards and these are going forwards. You could also draw it turned, so you end up with a square and 4 atoms in the plane. And then square planar is flat, so it can all be represented as atoms in the same plane.